Thermodynamics and the Creation of Elephant Toothpaste, presented by Olivia Williver.
Okay, in this experiment, we're going to make elephant toothpaste. We're going to use yeast, food coloring, dish soap, and hydrogen peroxide for this. First, we're going to add our hydrogen peroxide to our glass. I'm working with 3% hydrogen peroxide, but the higher percentage of hydrogen peroxide, the greater the reaction. We're going to add our dish soap to the hydrogen peroxide, a little bit in there, and then we're also going to add our food coloring. Okay, so we're going to mix some hot water with our yeast. And we'll go ahead and mix that up. And then we are going to see our reaction by pouring the yeast into this hydrogen peroxide mix. And like I said, the higher percentage of hydrogen peroxide, the greater the reaction. So ours is not a huge reaction because we were only using 3%. That's all we had at our house. But look at that, some toothpaste. You have to be careful because not only is oxygen a byproduct, but heat as well. So why does this reaction happen? It's because the yeast is combining with the hydrogen peroxide, and it's acting as a catalyst in removing oxygen from the hydrogen peroxide. The reason that we get such a big foaming reaction to create this toothpaste is because this is oxygen from the hydrogen peroxide in the form of gas being catalyzed by the yeast and then mixing with the dish soap. So how does this relate to thermodynamics? In addition to the gas being produced, heat is also being produced. That means that this reaction is exothermic. Exothermic means that the system is giving heat off to its surroundings. Since the reaction is exothermic, that means that the enthalpy of the reaction is negative. Since the reaction is exothermic, it means that it's producing more entropy to its surroundings. That means that there is more disorder, and therefore the entropy is positive in this reaction. Since the enthalpy is negative and the entropy is positive, then the free energy that is produced is more spontaneous, and therefore it is also negative.